mostly the rainfall events and extreme rainfall events over Bangladesh and how they change over time and predictability. So actually, like, it's very interesting. Like you see these two questions, like how are they changing over time and are they predictable? So I started working from the last part earlier. Like I started working on the predictability and prediction, and because from IRI we were working a lot in Bangladesh. We were working with the colleagues from Bangladesh Met Department. So I kind of involved on that work. But recently, uh, my colleague, who is Raghunandan Raman, who is a senior high in West Windsor, in New Jersey, he's a little boy. He kind of approached me to work something on the summer project. And I thought, oh yeah, we can actually working on the, like, the first part, like how they are changing. We never worked, although we studied lots of papers. But with the Raghu, that work started. And the first part of the work is mostly what we worked together in last summer, like still going on, like we started in 2 months back. And it was excellent experience to working with Raghu. And the second part, again, like working with Simon Mason and all our other colleagues from IRI. And obviously, I should mention our colleagues from Bangladesh Med Department. And I'm really glad that I see some of the names in the Zoom. They're online. I think it's a night over there, but thank you very much. So on that, I just start talking about today. So yeah, so I know like most of the people understand this thing, but just to start with, that we know that Bangladesh is a very vulnerable country in terms of natural disaster. And this is one plot from IFRC. I just took it, and there is kind of a special distribution of different kind of natural disaster, and mostly like flood and then drought and storm surge. It's really like a very interesting country with lots of impact of natural disaster and climate change. I just want to highlight specifically two disaster. One is like flood prone, like what is the flood prone areas in Bangladesh, and you can see like it's mostly lowland. So especially in the south, is a very severe prone from the flood. And also we know this is a country where they got like almost one or two cyclone every year. So it's also a cyclone hazard prone country. So it's very interesting to see like how this small country is actually experiencing almost every other disaster every year. And just to explaining what is the sea level rise situation there, although my talk is not on that, just to understand, because those natural hazards has a huge impact and indirect impact on sea level rise. And that's the map of the average sea level over Bangladesh. And is actually 10 millimeter. In some of the places is actually 5 meter. So, and this is the plot of where you can see the population density according to the uh, uh, height above sea level. So the population is very dense over that region, which is very vulnerable about the sea level rise. According to IPCC, in 2015, Bangladesh may lose around 11% of its land. And it's almost like affecting 18 million people, and which is 1 in every 7 people in Bangladesh. And that's the map is like, I copied from IPCC and Dhaka University's report. It's like a two scenario, what will be if there is a 1 meter and there is a 1.5 meter sea level rise. And we can see that's the region, like the southern part, which is also a flood prone region and cyclone affecting region. That was like mostly will be impacted on that direct sea level rise. So, and that's 2015, it's 30 years from now. So it's, in that sense, you know, it's very interesting to working, and very like this kind of thing motivated us to working on like how the extreme rainfall events, whether it's coming from monsoon or cyclone, they are changing over time, and can we predict those things in shorter time scale? So that's the background. In that background, I start with my work. And before that, I just want to mention what is the recent IPCC. It's not that recent, it's 2014 report, but what they are actually projecting over the rainfall and flood. So that's one plot from the RCP 8.5 scenarios. And it's mostly like, as you know, that the rainfall season is mostly summer monsoon. So it shows that at least that 20 to 30% the rate of like precipitation will be increased by 2015, and also the flood depth change in 2018 is more than some places 60 centimeter. So in that, you can just start. Sorry, it's somebody maybe microphone. Yeah, thank you. So on that, I just also want to mention what's going on in the recent year. So we know, like up to now, we understand like Bangladesh is like a very natural disaster prone country. Almost every year we have like they experience like either flood or drought or heat waves, everything. But this year is especially is very interesting because we know like the COVID situation, and right now it's really bad. But think about that in month of like we started this thing in Bangladesh maybe somewhere in the March or April, and then in May there's a huge cyclone. It's called Amphan. Is there, and it's actually like a super cyclone category, and it's devastated the country and also like the eastern part of India. And you can see like how people are rescue with their PPE because it's a very it's a kind of compound risks like we have to evacuate the people, like they have to evacuate the people, but all the cyclone shelter like center, they are not such big that people can maintain the social distance. So it's actually a huge jump of over the infection rate on that time around in May, and it's a big news that time. And in fact, like I'm from India and I'm from Calcutta, so my family also affected on that. So it's a really a big natural disaster in recent year. And as I have experience working on the South Asian monsoon, and I have seen like wherever there is a cyclone, especially in the like late cyclone season, which is May or early June, if there is a cyclone, then we can expect that the monsoon will be delayed or the monsoon will be not that much of it like active. And that happened in 2019. There is another cyclone, it's called Fani, in May. It was hit the same area, and it actually caused the monsoon delayed, and the first half of the monsoon is very deficit. So we also expecting that thing, but this year is totally different. Like monsoon 2020, which is still going on, we are in between this season, is totally in different phase. It like monsoon come very timely. In fact, it's come a little early this year, and then almost every week, especially that part like the eastern part of India, including Bangladesh and northeastern part of India, having almost every other week have a huge rainfall episodes, and which actually affected a huge amount of people, especially with this COVID situation. And like one report by IFRC, they said like more than 4 million people are at risk of food insecurity and disease because of flooding, and right now it's still going on. So this year is really interesting, and we can see all the natural calamities this year is happening. I don't know when it will be stopped, but those all things actually motivated us and working with our colleagues from Med department whether we can predict it and how they are changing over the time. So from now I can just start giving the answer of my first question, like how they change and what is the return period of that kind of events. And for this particular study, we just choose 3 indices, although like we studied all 27 indices proposed by expert team of climate change definition and indices. So for this particular talk, I just took these three and try to calculate every station over Bangladesh, which is the data given by Bangladesh Met Department, and how it looks. And this is just for the recent decades or last 2 decades, 1998 to 2019. And with my colleagues, Carlo and others, we calculate this thing, which each station, what is the mean of maximum 1 day rainfall, maximum consecutive 5 day rainfall, and what is the annual total precipitation get at the 95th percentile. And as it is mean, we can't see much information about that because it's a mean over almost 20 or 25 years. So we don't get some idea, but we see there is some special distribution on that. And that's what we did. We actually studied each station individually and dig more and try to understand the trend, the non-stationarity, the detection. We try to detect the stationarity in the data set and then all the other things. So we did for each station, but for this talk, again, like we don't have much time. So I just focus on one particular station, which is the capital of Bangladesh, Dhaka. And reason behind choosing the station is not only that we have a lot, like we have a really a good historical data set, because most of the station, they don't have much historical data set. That's what for this particular plot is actually from 1988. But for Dhaka, we had a data from 1975. And also another point, like another disaster point of view, that Dhaka is actually impact, like having impact of urban flooding because of that kind of rainfall, the extreme rainfall. The next slide I can explain more. So yeah, so Dhaka is like a very overcrowded city, and I was there a couple of times, and I see like if there's a rainfall, like the how the communication and everything is in tough situation. And it's a place of 18 million people, and it's almost like every year they experience that urban flooding. And there is a lots of study on that by World Bank and uh, Bangladesh government, that how they can study, like they can manage this flood risk in terms of management and others. So on that background, we choose the Dhaka station and we try to find out like how those extreme rainfall changing over the time. So this is an interesting plot called violin plot, and which is actually a complementary plot of box plot in statistics. Like like the box plot is giving us a, a description of whole data set and how, like, what is the quartiles and what is the median and what is the outliers. And in this violin plot, we also add that distribution aspect, like in violin plot, they calculate the kernel method to calculate the distribution. So this is like a distribution of 3 indices for Dhaka from 1975 to 2019. And it looks very interesting, especially when I see the first time this plot, especially the RX1, the things come in my mind, like what happened in those, like why it look like this, like is there like a gap of data or what's going on? Then we kind of diagnosed more, and we plot the histogram, and the histogram looked like this. We found there is like a the data range up to 200 millimeter, but suddenly there is a gap, and then some incident happened which is in between 300 to 350. So that actually triggered me more interest, and then I started looking more. And when we plot those data over the time, and I see there's two data points and look like outliers. We may, like, we don't even know like whether it's outliers or not, we should remove it or not, because it's a it's an old record. Then we kind of go back and try some search and try to find out some newspapers and what happened those years. And some although, like like unfortunately there is a very few study exist over those kind of problem, especially over Dhaka, that we cannot validate our data with other study. So we kind of do like subjective way. And I found like two interesting news story. One is in 14 September 2004, which is exactly the same data we have. And another thing is July 28, 2009. And both of that day, like Dhaka was flooded. And one of the, like, the biggest flood in 53 years, which is occurred in 2009, and the worst flood in 2004. So, like, that's why, like our study is not only the data analysis, which also we try to understand like what is the story behind each of the data, and you go back and see these things. So that's what, like, we kind of before we start the train or the thing, we kind of check the data point very thoroughly and try to understand the distribution of the extreme rainfall. And on that, we try to find it out, like the nature of the non-stationarity and trend. And you use like a most standard method, which is Mankandel, sense slope, and you also use the augmented Dickey-Fuller test for whole data period. But when you calculate those things, it's interesting that we don't find any trend, or we don't find any non-stationary behavior. Because like you see that trend line is look like very flat, although it has some slope around 95, but it's not statistically significant. So most of the cases, so we don't understand, like, okay, so things are changing. We know like there's IPCC report, everything is there, but why it's not coming in our data, which is from the Bangladesh Met Department. Then we try to do it in a different aspect. We try to do it for each decade. And when we actually distributed this study each decade, it shows a different story. And we understand for our X1 or X5, there's two extreme rainfall. So that's what the trend in that 2000 to 2010 is a little different. But if we look at the other part of the data, other decades of the data, there's always a trend. In fact, there is some increasing trends, there is a decreasing trend, and some of them is really significant, some of them is not, depending on the the data period. But if you look in the R95, there is sharp change in 2000 to 2010. It's like decreasing trend, and also another like some increasing trend we found. So what do you understand? Like, we have to take care of the data analysis in such a way that we kind of filter out the information instead of just looking all over this data. And you also calculate the Dickey-Fuller non-stationary test, and we found some of the decade is actually non-stationary. So that's kind of, we try to understand like how they change. Now question is like what is the return period of that kind of incident? And for that, for that we try to fitting the generalized extreme value distribution on those data. And again, so this is like ongoing work. So we just started with this thing, and we kind of making more complicated or sophisticated method in future. But just to explain, like, we try to understand, okay, so this is the thing, and can we fit GV and try to understand like what is the return period, what is the characteristic of return period. And GV is actually, as we know, most of us in this call, that it's a mixture distribution with three distribution. It's mostly depending on the shape of the distribution, how it looks. So we try to fit those distribution for each of the indices. But we thought, although we don't find any trend, but let's see if we put the trend in the parameter of the distribution and how it looks. Like instead of putting the trend in the data, if we just impose the trend in the location and the shape and the other parameter in the GEV, whether we can get more information. So that's why we try different combination of GEV and feed the data. So here is the intercomparison of different methods, like original, training location, training scale, or training both. And we kind of compare this thing with a very standard goodness of fit statistical score, which is called Akaike information criteria and Bayesian information criteria. But what we found, like the original one, which is without any trend, it's the best one. Although if we looked at the value of the Akaike and BIC is not much difference for each of the model, but at least we can see that's the lowest with the original one. And again, we found that may be the reason, because we actually fit GV with the whole time period, right, from 1975 to 2019. But if we can put it in a different decades, that's what we found, the trend, different trend characteristic, different decade, maybe we can get some different information. So that's, as I said, is an ongoing work. So that's one of the information. And another thing coming in our mind, another thing coming in my mind, like, okay, so we kind of playing GV with the trend, but can we play GV with the seasonality aspect? Or can we try to fit the GV with a covariate aspect where ENSO or Indian Ocean Dipole or something else, like in terms of teleconnection, is an impact. So in future, we are thinking about like imposing those information in the GV and try to find out the information. So anyway, so based on this study, like using the original GV method, we calculate the return period, and the return period look like very similar kind of pattern for each of the indices. although the amount of the rainfall is obviously different because the nature of the indices. And we also have a like a kind of a bigger confidence interval. And that also one of the reasons that we are looking for maybe another GEV, or we can use some other like GPD or uh, different like special uh, like other distribution to find it out. So that's kind of the picture we found based on the original GEV. And yeah, so, and again, as I say, like that, there's a part of our ongoing work. So we're still working on and for try to find it out what is the best way to find out the information. And this is the picture for only one station. We also did for other station, and the other station also looked different, obviously. We also try to fit the spatial extreme values, because like those stations, especially in the south, they are not that far. And if there is a one incident happen in a one station, obviously it will be the other station. So we cannot treat those as independent. It's kind of all dependent way. So we are also in our plan to use some dependent kind of or spatial covariability in the distribution of extreme value. So on that, we kind of discuss about how they change and what will be the return period based on our study. Now the question is like, are they predictable in real time? Because we know like things are changing. By 2050 it will be like this and that, but the important thing is like, for the society is very important to have this kind of information in real time, in shorter scale, that people can actually react. Although like we know like the cyclone is always like predicted by 5 days or 4 days, and people actually getting those information. But can we predict little longer scale, like in a seasonal or sub-seasonal scale, or not the cyclone or the rainfall pattern, those kind of things? So in that sense, we start the second part of this talk is we can have a seamless prediction system. And uh, this is a uh, graphical representation of IRI and IFRC's work, where they call ready, set, go. So we should have a different kind of forecast system. Like obviously in seasonal forecast, we cannot predict when will be the cyclone or when will be the extreme rainfall event, but we can have some outlook, like what will be the season, whether it will be like mostly having more rainfall events or heavy rainfall. That kind of information we can get from the seasonal scale. And then we can have some more specific information in between, which we call subseasonal scale. And then obviously the meteorological department in Bangladesh, they predict their short range scale, which is for 4 days or 10 days. So obviously we can react. But in terms of like how to deal with those extreme, the planners need to have some information beforehand, not like 5 days before. So we should have like a seamless prediction system. So in that respect, IRI and Bangladesh Met Department is working almost like 4 or 5 years from now in different projects. So we are actually trying to help or working closely with Bangladesh Met Department to improve their seasonal forecasting as well as sub-seasonal forecasting. And so these are like most recent involvement, although we work a lot, like IRI and BMD is also part of South Asian Climate Outlook Forum. We also had a project with supported by USAID, which is called Climate Surveys for Resilient Development in South Asia. And most recently, in Colombia World Project, like First World Project under Act Today, Bangladesh is one of the country. So on that, we are actually working with them from last couple of years and also continue this work and try to improve their system. First, try to understand their system and try to improve their system, and try to make that system as per the WMO's guidelines. So in that, I can show what up to now what we have done with BMD. So the left plot is showing, or the left graph is showing like how they make the forecast earlier. It's called all like subjective consensus. So every season, especially for the monsoon season, they're kind of looking different forecast products within global producing centers and others forecast center, including IRI. and making a subjective consensus or a text, like, that will be for the all over the Bangladesh and this and that. But now, working with this project, we kind of develop a system called next generation focus system. And I'll come on the next slide, what does it mean. But the one of the thing is, like, we should have a, like, a geographical map of the rainfall events and what will be there. And also and for that, it's like, it's a it's a series of work. And the first thing is, like, we have to develop some high resolution data. So up to now, I show the maps based on the station data from BMD. But for the modeling, we need a high resolution data. So we develop with IRI and BMD collaboration, develop some high resolution data, which is 5 kilometers apart, and merging between the station and in the satellite data. And we also uh, advanced the seasonal forecast system using more advanced tools, climate predictable tool developed by Simon Mason in IRI, and we now have a different interference based on Python. And this system is actually, like, when they have this whole system, so we did some research and study and working together. And then the system actually in place from last November 2019. So we can see that how those forecasts going on and what the scale in couple of slides. So before that, I just want to mention, like, what is the next gen forecast system. So in a very recent guidelines by WMO, they mentioned that the seasonal forecast procedure should be traceable, reproducible, and well documented by a set of steps. And because the subjective consensus is kind of, using the experience from the meteorologist, so we cannot trace or reproduce that kind of things. But if we use kind of dynamical model based forecast system, we can always reproduce. So we mostly using the climate models from North American multimodal ensemble projects. But as you know, like, you can't just use the model as it is, because of the resolution problem, because of their skill issues. So we calibrate those models based on the real, the ground truth from the data of BMD. And that's what, like, this is the, like, kind of graphical representation, how we make this forecast. Like, we kind of correct each model based on the observed data using different calibration method. And then finally we make a multimodal ensemble. And for the calibration, we use a climate predictable tool, and we use mostly kind of spatial correction method. Right now we are using canonical correlation, but we're also using different kind of method called pre-simple component regression or simple regression. So that's the whole system right now which BMD have. And but we have lots of challenges. It's not like, in theory it's easy, like we just download the data, do something and have some focus. But the geographical position of Bangladesh is such a way that the skill of the models is not so good. And sometimes it's not even usable. So we kind of, do some background research and try to understand what is the skill of the raw models and how can we improve the scores, those skill. I'm sorry. So right now in the screen, you can see the correlation and the root mean square error for different models. And particularly this example for monsoon season, and which is like a May initial condition forecast. And you see some epoch, or like some hotspot of skills of some models, and most of the models is not that much of skill and they have a huge RMSE. So we try to understand why the, like, what's the problem with that, and what is the source of predictability of the models and why they look different. And then we actually calculating that empirical orthogonal function, and the first two row is actually from the observation, and that's what is actually over the Bangladesh, and from the others is actually from the climate model, so you can see the bigger domain. So in terms of the first and second UAF for this particular season also, like you can see there is a mismatch between the model's spatial patterns, like principal patterns, and the observation principal pattern. So we understand that may be the reason to have like poor skill. Then you go a little further, we try to understand, okay, so like the seasonal forecast is mostly coming from the ENSO, the predictability coming from ENSO, and how it looks inside the model and how it looks in the observation. So the first plot of this spatial plot is actually from the observation, like observe rainfall from BMD and SST from NCEP. And we see, especially on that tropical Pacific, the correlation is kind of positive. But this is like some of the models. I did not put all the models, but if you look to some of the models, one of them is GFTL, one of them is Canadian model, and one of them is from NASA. Like most of the model is actually capturing like having this teleconnection totally different sign. Like in the model is actually different, like it's a negative correlation, and that may be one of the reason that the models uh, could not have a good scale, and that is the reason we can't use the model as it is. We have to use some kind of calibration, and that's what we use the calibrated way. So we can see one example, like it's a one particular individual model. I think it's a Canadian model. So the left side is non-calibrated, right side is calibrated. So, and the upper band is RMSE and lower band is Spearman correlation. And you can see there is an improvement of the scale. Like most probably like the bias, the mean bias is reduced a lot. The correlation is improved, but some point it's also reduced, but it depending on the models and the season. The thing is, based on that method, what will be the scale of the final product? And that's the final product. It's like again for the monsoon, this is like a calibrated each model, and then we make the equal weight MME, and then we calculate the scale. Although the scale is not super high, but at least, like if you remember the previous slide, the scale of individual model compared to that, this skill is much better. So based on this system, so we did this kind of study with the BMD and others in IRI before we actually place this system, because sorry, so because it's like we're not using any tool like black box. We're actually try to understand the system and then try to implement this forecast system. And in that, we can try to see like whether we can predict that real-time monsoon 2020, because this system started from November 2019. So we have only one example in real time, although we had past forecast or hindcast, we see different monsoon every year. But I don't want to show those kind of things because obviously there is a research element there. We can see which model is good or bad, but this is an example of real time. So first of all, before going to the Met Department, Bangladesh Met Department new forecast system, try to understand what was the raw forecast from the NMME models. Like this is the picture of the NMME models. We can not find Bangladesh because it's a very small. But if we just zoom that part, and you can see, so the left hand side is like May initial condition, June, July, August, and over Bangladesh we can see no signal at all. In fact, you can see some signal of below or normal. And then the right hand side, which is again the next month, June initial condition JJA, we see some kind of above normal signal, but it was not at all clear because of the big map. So this was like a raw models. But based on that, so wherever like people making the subjective consensus, they look those map and try to understand what does it mean. And if we make the forecast based on that, we don't have any idea that the monsoon 2020 will be so havoc. So now it's the BMD's next gen forecast, and that's the real time. So they made it in every like month for next 3 months. And also particularly for the season, monsoon season, which is consist of 4 months, they also made that may start for 4 months. And this was also discussed in the South Asian Climate Outlook Forum in real time in May and April. So from this forecast, starting from the May, we get that signal of the above normal rainfall, although the probability is not like super high. And it's understandable because in seasonal forecast we can't find a super high probability if there is no impact of ENSO, which what we found, like the correlation of ENSO and Bangladesh is like not that much, is maybe 0.2 or zero 0.3. So that's what, but at least we can get some outlook to have some idea, like having a heavy rainfall. And based on the real-time data, and that's the situation right now. So based on the high resolution real-time data from BMD, we just plot the observed category from June to July. So that's the right now situation. So most of like, I see like mostly northern and central part of Bangladesh is over the above normal, which is more than 67 percentile from the historical data. And there is some scanty rainfall or below normal rainfall in the south, but we can see like it's only 2 months, so maybe, and still the rainfall is like it's going on. And right now I think last week there is another depression in Bay of Bengal. It caused lots of rainfall. So we can see this real picture at the end of the season. So that one thing. And second thing is like, although we're talking about seasonal forecast and we show mostly three category map, but sometimes it was not so much helpful for the planners. Let's say for the agriculture planners or dam management. So they need kind of a specific threshold based forecast. So for that we also develop with the help of IRI and BMD, like we call flexible format of forecast. So if we look, this is a one dashboard or map room developed at BMD, and we can actually change the field, like we can change the field from tertial forecast to probability of accidents, and you can also particularly put a amount of rainfall which is we are interested to see. For example, I'm the planner of an agriculture planner. I know for such a crop we need that kind of rainfall over the season, and I'm looking for what is the probability of having at least that kind of rainfall or above. I can put that value there and then see the map. So the left hand side actually showing the probability of exceeding 800 millimeter rainfall over Bangladesh. And then if I interested just one subdivision, let's say here I just select this subdivision. I click there. When you click there, you can see these three different graphs, and the blue and the black one is actually the climatological distribution. One is based on smooth and one is unsmooth data for that particular region from last 28 years or 30 years. And then the red PDF, red probability curve is actually from the model. So from that, we can understand like that whole distribution of forecast instead of only three category. And also we can change, instead of having a particular rainfall amount, we can also change the percentile. Like if I'm interested on different kind of percentile, it's starting from 5 to 95. So this map is for 55 percentile. You can have an idea like what will be the median of, this is like almost like median for this season. So and that's also part of the next generation forecast system. So it's not only how we make the forecast, it's also about how we present the forecast, which is actually based on the user feedback. So on that, so this is all about seasonal, but the question is like, what about subseasonal scale? So again, this is like ongoing research and development work with BMD. So we are still working on that, and we need time because as we explained, like before we making this real-time forecast seasonal forecast, we make a lots of research. So right now we're in that stage. We are working with BMD and we have a plan for a couple of trainings, and some trainings like used to be happened 2 months back, but because of the COVID, we cannot do it. So it's a little slow right now, but we're still working on that. But before that, like I just want to mention like what is subseasonal scale and things. So subseasonal forecast system is very interesting and very recent, and it's actually a project called S2S Project by WMO WCRP, and it's actually chaired by Frederick Wittrat and Andrew Robertson from IRI. So right now, this project in phase 2, where is actually research to operation mode. Like, okay, so there's a lots of research going on in different S2S modeling, but now the phase from 2019, we're actually in that phase where you can actually use those forecasts in real time and see how it impacts. So as we don't have any results from BMD side, but we can see like before going to the real-time forecast, what is the scale? And this is I want to see this. I want to show the scale from the IRI forecast system. So right now we have the real-time subseasonal forecast system, which is have a different product in every week. Our colleague running, and we're part of that. So we just try to understand, like example, like what will be the features of subseasonal forecast and how they will help us. So based on that forecast, I just give one example. So this is an example of uh, for I'm sorry, the date was wrong. It's actually 17th April. So I'm sorry, it's not. It's 17th April forecast from 25th April to 8th May, which is a forecast from week 2 to week 3. So which is the average of 15 days, which is start from week 2 to week 3, and we get that forecast. And we see there is some signal which is more than 50% over Bangladesh. And I remember I communicated this information to our colleague in Med department, and that's the week just before the Amphan. And we don't even know that week that there will be a cyclone or not. And we see like lots of probability over the Bay of Bengal and North Indian Ocean. And then I can see what happened in the real time. So this is like a 15 days rainfall, like everyday rainfall, and from National Center for Medium Range India data. And we see some of the days like 25th, 27th April, 2nd May, 3rd May, 6th May, there's a huge rainfall over Bangladesh. And at the end, if we calculate the percentile in terms of the historical data, we see there is like more than 70 or 75 percentile over whole Bangladesh. So this is one example like where we can actually get some information, like that ready set go. In that set, like we can get, first of all, we can get a seasonal rainfall forecast where we find, okay, so there will be like heavy rainfall, and then in subseasonal scale in week 2, 3 or week 3, 4, if we get that kind of information, and that also huge important to deal with those disaster. So that one example, and I'm sure in future we have this example from BMD itself. So right now it's in construction. So I just want to give some example like how we make this forecast. And also this is like after next week, we also find out the forecast for the Amphan. We got like a huge above rainfall. I don't want to show because that was like, it's like a benchmark, but I want to show the before week, because before week also a heavy rainfall. And think about that, it's already a heavy rainfall episode going in Bangladesh, and then there is Amphan coming. So that's what, like, the situation is much worse because it's already have above rainfall episode going on, and we also captured those kind of information. So in that, I just want to take a break and ready for any feedback and comments. Thank you very much.
Thank you very much. That was very interesting. Do we have any questions from the group?
Do you want to read the chat or something? Somebody...
Just give it a moment. Sometimes people trying to unmute themselves. There are a few comments in the chat, but there were, I believe, earlier on in the talk.
Yeah, actually, I have a question. The extreme rainfall events that you saw in 2004 and 2009, were they from during the monsoon, or were they associated with cyclones before or after the monsoon?
This was actually in the monsoon time, because one is in September 14, 1-4. Let me go back that news. And one is in July.
Okay.
Yeah, so that's, you can find here. So it's actually 14 September, and another is like July 28. So it's actually best for the monsoon, not for the cyclone.
Hi, Lucy.
Hi, who's that?
Hi. Yeah, thank you. Nice presentation. I am very interesting thing that two event you are explaining the extreme rainfall. One is September 2004, about 41 millimeter rain occur. Another 28 July 2009, 333 millimeter rain occur. This is the two extreme event last 15 years. My question here, have you possible to return period this type of extreme event occur coming next 30 years or 50 years? If it's possible to find out, that we can gauge 1, 3, 4, this type of, we can very easy to take decision or planner.
Yeah, thank you, Bazrul. Bazrul is from PMD. Thank you very much for your comment. And that was the whole reason for this study. And that's what, like, we fit GEV and try to understand the return period. Although, like, this particular plot start from 20 years return period, but we can actually calculate for starting from 5, 10, 15, 20, 30. So we can do that one. So yeah, so that's the motivation of this research. And we're trying to understand what is the return period of those kind of havoc rainfall incident. So there is another question from Vivian. Are you also going to examine the impact of sea level rise and coastal flooding combined with extreme rainfall from monsoon cyclone? Oh, that's a really interesting question, actually. But yeah, yeah, but my field is not actually working on that. So I'm interested to working and I'm interested to collaborate with anybody like who are actually expert in sea level rising, because as you said, like there's a one-to-one relation between the coastal flooding and extreme rainfall. So yeah, although it was not in my plan, but I'm ready to collaborate anybody or with you if you're interested on that work. Thank you.
Hi, Nachi. Really nice presentation. Thank you. I think also just going on what Mike mentioned and some of the comments were sometimes, especially in northern Bangladesh, maybe a lot of the flooding also is because of extreme rainfall higher up in the watersheds along the Himalayan ranges. And if in the model that's specifically being run by the Bangladesh Met Department, how is this kind of upstream extreme rainfall that's outside the boundaries of Bangladesh, so Nepal, Bhutan, and northeastern India, how is that being incorporated into this assessment of uh, trying to better understand the likelihood of flooding in Bangladesh?
Thank you, Mukund. It's a really interesting point. Yes, so yeah, I saw that Michael's took, comment on that. Yeah, it's not only the rainfall over Bangladesh is coming from the river, mostly from the Bihar and Nepal. So it will be great if Kamrul or Bajrul from BMD reply on that, because my understanding from what I understand from BMD, like BMD is not responsible for making the flood forecast, it's rather like Water Commission in Bangladesh, and they use BMD's forecast as an input and run their flood model. And Peter Webster also have a huge work on that. So Kamrul or Bajrul, you want to reply on that?
Yeah, actually, in our country, the flood, especially the rainfall, inter Bangladesh, it is not contribution. Especially the flood main causes the rainfall outside the boundary of Bangladesh, especially the Assam, Meghalaya, Bihar, Nepal. This season when the heavy rainfall occur, that time this rain contribute the heavy flood. And when we are running 10-day model NWP, then we can gauge the amount of rainfall in this model. Then we input this data at FFWC, Flood Forecasting Warning Center. It is another department. They input this data and they forecast the flooding situation in Bangladesh.
Yeah,
Yeah.
thank you, Bajrul, and thanks, Kamrul, for your comment that you said 93% of rainfall outside Bangladesh is responsible. But the question is like, in the real time, whether Bangladesh Met Department or Water Commission get those information from India or Nepal when they make the forecast, like how they use those information, which is outside of Bangladesh, to make those flood forecasts. Do you have any idea on that?
India doesn't tend to share the water level data.
Okay, Michael, I don't know about that.
If I can jump in really quick, if I remember correctly, talking to the Flood Forecasting and Warning Center about flood forecast, they have a model that includes the whole sub-region, but then they're only responsible for the flood forecast within Bangladesh. So they have a model that looks at what's happening outside the boundaries, and then they look at the boundary points and they make their forecast based on what's expected at the boundary points and then how long it's going to take to flood other parts of Bangladesh. So they have a model that includes it, but I don't know the details about that model.
Thank you, Melody. Thanks for the comments. Okay.
Do we have any other questions?
Yeah, I was going to mention, Peter Webster developed a model for Bangladesh for using the outside models to help predict flooding in Bangladesh.
Yeah, I remember like a discussion with Peter, I think 2 years back in Noah, sorry, in Anchor. So he actually explained, and he explained his frustration, like how tough it is to use those information from different country. But it seems like, although you said like they did not get the information from India, but I see like Kamrul from BMD, he takes that they are getting information from India. And I think that's a part of the regional storm warning center, maybe RSMC, I forgot the full form. So they're getting those information, I think. In fact, like right now, there's a huge flood in Bihar, in the Koshi River, and which is also impacting the Ganges branch in Bangladesh. So I think like those kind of information they're getting.
Yeah, they're getting some data, but it's not as long term as you would like.
Oh yeah. Maybe they got the real-time one. Yes.
Do we have any final questions? I see Michael maybe has something to say. Yeah. Okay, I'd just like to say thank you very much again, Nachiketa, for a really interesting talk. And thanks everyone for joining us. I hope you have a really nice rest of the day.
Thank you, Craig, and thank you everybody. And thank you, my co-authors.